Mark, cannot hear you.
Sorry, I was muted. Didn't realize. All right, so I don't think that we're going to get Sage today. He is out this week, so it might just be a pretty small crowd today. Uh, and I don't have a ton of stuff to go over, so I think we'll wrap this up pretty quickly. Um, well, people have had some time to join. I guess we'll just get started here. Um, there are a couple of new PRs this week. One that I'm somewhat interested in here is that Sage is increasing the cache size of the Mon. I think the RocksDB cache size as part of this specifically, um, and that kind of flagged my interest because of all the work lately on auto tuning the cache size of the OSDs. I I tend to wonder if we should be doing this everywhere, even if it doesn't seem to make sense at first, to just say, okay, here's what we want the OSD, regardless if it's Blue Store or File Store, to kind of consume. Here's what we want the Mon to consume. Here's what we want the MDS to consume, RGW to consume, et cetera, et cetera. Um, and then tune cache sizes kind of appropriately. It may not necessarily change that much on like the file store side. Um, all we're really doing is I guess the RocksDB cache really doesn't matter nearly as much there. Um, so maybe it's a little ridiculous, but it would be really nice if, from a user perspective, they could say, okay, here's how much of my memory I want to carve out for these different things. Um, we have some, kind of minimums that we suggest for everything, and then just kind of, make our daemons conform to it, even if we're potentially giving something like the Mon, more cache than it really reasonably needs. It'd just be nice if everything kind of fit into boxes that we give them. So I'm still kind of leaning that way myself, but in any event, it sounds like we were not giving them on enough cache initially. It was like 128 megabytes, and bumping that up fixes whatever this issue that was run into is. So um, if you're interested in this, that appears to be what's going on here. Um, Next one, Radek, you've been working on a variety of things, including killing backward iteration in the buffer list. Do you want to talk about that at all?
Sure. It's one of the PRs related to cleanups, basically cleaning up the buffer list. Well, it turned out that we offer that implemented that currently buffer list offer backward iteration that seems to be used by very few users, but pretty prominent, and to do things that can be made actually a bit cheaper. I mean, especially our encoding macros, encode start, for instance, uh, it takes, it needs backward iteration to to allocate some to allocate space for things like size of the uh, serialized data that follows the encoding preamble. Uh, it's computable only after doing that, after doing the real serialization, and those data are injected and are basically written twice. At first, some chunks, then the correct value is put there. I decided to replace that mechanism to kill the backward iteration and replace it with some kind of whole appending. Instead of encoding and really mem copying some chunks, we are just preparing a whole and returning a very thin abstraction over dump pointer. Well, in testing, I think I posted some comments with output from profiler there. Let me link the PR. Here it is. It gives maybe 1.5%, something like that. Not much, but I treat it mostly as a cleanup, as a simplification of interfaces. I have also a branch that kills the append buffer we have in buffer list. The idea is to always try to append new things just to the very last buffer. Of course, if it's possible, if we are a real owner of the buffer, of the last buffer. Still, it needs some refination, but I plan to send in just after finishing the stuff with Ceph containers.
How often are we appending new buffers to the list as opposed to adding to the last buffer in the list?
Well, I took a look on that with Profiler and it seems the most prominent method of buffer list is the C-string taking append. C-string,
Yeah.
not appending some parts of other buffers or something like that. No, just regular C-string variant of append. And we are paying a pretty high price when it comes to using it in its current form. It's because we are always appending to append buffer, then creating a buffer pointer from those used space. Then, if it's possible, we are merging the stuff with the last buffer. Well, it's pretty costly. Let's try to imagine you want to put 8 bytes, and we are doing that over and over because the buffer, the append, the C-string taking append is not inlineable. If you take a look on of typical encode function, well, there's a long sentence of calls to just to the C-string append. And even if we put that currently implemented C-string append to header to let it compiler inline, I'm afraid we will just end with very inflated encode methods. It's because how it is currently implemented. It tries to utilize all really to the very last byte available in current in the append buffer before replacing it, and it does that in a loop. Basically, it can. I have a commit that just turned it into basically two stages. First one, try append as much as possible to currently existing buffer, append buffer. Then, if really necessary, then just allocate new one and write them there what's left. But I would love to see. I don't know whether it's even possible, but I would love to see a compiler that inlines all those methods and tries and verifies whether we have enough space only once. That was
Yes.
the thing we made with new perf counters. Perf counters are implemented in a way that tries to use per thread storage. We have pre-allocated space for up to 32 different threads. And if it's not possible, if we saw another thread 33rd, for instance, then we are going with shared perf counters data. But the check is made in a way that that addresses typical use case of perf counters because they are used in graph. It's not so common to see one single increment over one single counter. Usually, you are manipulating many perf counters in the same place. So the stage of verifying whether our thread we are using really has the necessary memory is made once for all those graphs. I would love to repeat that pattern in buffer list, but still I'm not sure whether it's possible. It's a matter of data dependency.
Radek, do we have any info, or do you happen to know how often that pattern kind of shows up? The specifically the append kind of pattern you're talking about.
Well, I think it's present in almost all encoding methods using not using the continuous appender. So basically everywhere outside Brewster.
But I imagine in some places it's much worse than others, right?
Yeah. For instance, GH object encoding is pretty painful and is used very commonly.
Second.
During random reads, I can see that serialization of MOSD reply is a pain.
Some last week
Okay.
after our last performance meeting, I started making this thing, which I didn't finish because I got sucked into this RBD stuff. But I thought that that if we can start documenting some of this, kind of where we're spending a lot of time, specifically in the object creation destruction, and then I actually kind of noted append here as well, as kind of a highlight. Might be good to know, but maybe all this now is going to be irrelevant with the work you're doing. So and now already this is all very out of date. This was Pet Store from like 6 months ago. But when you talk about encode and the list appends, in these tests where it was, I was kind of trying to make the backend as fast as possible and also eliminate a lot of the other stuff that shows up a lot of times. Certainly encode and list append showed up a fair amount in the messenger worker threads.
Yes, it's because at least in my profiling, I saw that that messenger is actually responsible for crafting the message to be sent to client. TPUSDTP just calls send message, but there is a check actually on that path. If MS can fast dispatch would return true for MOSD reply, then this buffer serialization would be made by TPUSDTP, but it's not. We are returning false. This means that that the pointer to message is just put on out underscore q of async messenger, and it's taken in next swap of the event loop we have there. So messenger is responsible for crafting the message, and what is even more painful, because I hacked the MS Scan Live dispatch just written to also for OSD reply, and it seems well, Messenger it got stuck in doing in freeing memory. There is huge traffic generated to the central caches of TCmalloc. I guess it's because most of the things in OSD reply are generated by TP, by TP OSD TP, and
Mm-hmm.
then they are freed by completely different threat. Pretty critical to the performance of all system worth adding, I guess.
Sorry, I ask this every week, I think, but when you were seeing that, was it with how much thread cache did you have?
Running defaults.
Defaults for Ceph or defaults for VStart?
Yes, but okay, Mark. I will give it a try using 128 max.
Both. Let's try both.
Sure, but still,
um,
the question is how. Of course, it leads to another question. What is the what is the average value people use in the? I'm
I
not sure
believe
whether anybody tries to that parameter.
we as far as I know, like 3 years ago when we did all of this last time, we set all of the OSD initialization stuff for System D to use 128 megs of thread cache. So I think in real deployments it should be using 128.
Okay, interesting. So
So
it
that's
means that our start is just not mimicking the reality correctly.
yeah. But I 100% admit I believe this is a crutch. I think we're relying on thread cache here to solve, a nasty problem that we're just kind of wallpapering over, right? Um, and if
Well, it's always PC can be very fast when you don't where there is no contention, where it can close all the requests, not going outside the thread boundary, the thread local storage boundary. Then it's
yeah,
perfectly fast. Uh, but I'm afraid that memory flowing between threads always a problem. In
yeah,
libc it's not so visible because even making a single thread allocation thread sorry even making a single thread memory management is still costly because you always have an atomic inside on the main on the hot path always. Well, I think that T-Star can actually do that, uh, can help with that because it's just zero sharing thing by design.
yeah, yeah. As long as we don't break it too badly by kind of doing unusual things, right?
Yeah.
Um, okay. Well, anyway, I suppose we should move on here, but yeah, I'd be curious to see how much difference you see with larger thread cache. I suspect it will look a lot different, but I think that was those tests that I did in that other Etherpad. Those were with 128 megs of thread cache. So, there's less, there's still some TC free stuff showing up there, but it's more the things that seem to be obvious here are object creation and deletion and encode and list append and that kind of stuff, which it sounds like you're already working on. So I think this is gonna be really good. Um,
Well, as said before, I will give a try to the 128 and just the standard settings of Vstart.
Sure. Sounds good.
I can also, I can, I guess that the TC traffic popped up also using CBT for testing and profiling in a CBT deployed clusters.
Okay. Okay.
At least for the weighted priority queue.
In your CBT settings or in the YAML file, do you launch the
Yes,
OSD with
there is huge
128
cache
thread
there.
cache? Yeah. Okay. Yeah. The default one or the one that I usually set is like 128 megs then.
Yep,
Okay.
it's your configuration.
Yep. That's 128 then if you haven't changed it. Okay. That is
But
interesting then.
but still, I haven't profiled exactly for that. Maybe it shows in this really single critical place, the interconnector between messenger and TP-USD-TP threads. Maybe it just maybe other places are free of that. I don't know.
I think it would be a really good goal if we could make Ceph work well no matter the memory allocator that's used and kind of regardless of the thread cache, right? If we can kind of take this whole problem out of the equation by just
I
making
see, but I am
clean
afraid.
memory allocations and handling it ourselves.
Yeah, but it can boil down basically to squeezing some dynamic allocations.
I still wonder a little bit if we could get there if we start adopting a behavior of reusing objects and not creating
Yes,
and
it
deleting
can
new ones.
help. It can help, but still we will need to somehow. I bet we will face the situation where objects, not just even memory, just objects, layer above, is still traveling between multiple threads. I would
Yeah,
expect that op request will be created by messenger, passed to TP, and then maybe even to finishers, and then freed.
yeah. I think you're probably right.
So still, we will need some synchronization mechanism, but maybe the synchronization per se could be done much less frequently, saving some resources.
Cool. All right, let's move on. I think we're losing people over time. They must be getting bored of our discussion.
Looks like so.
Yeah.
Sorry,
So
guys.
there's this. No, it's okay. It's good. I think. Um, so this librd thing. I don't know anything about it. I think eventually Jason will probably look at it. Reduce the token bucket fill cycle and support bursting IO configuration. I don't know anything about that. Um, and Ilya is gone. He might have been the only one that could say anything. Um, all right, I think everyone here has heard. Well, maybe except for Casey has heard this stuff about the XFS default AG count. Casey, for your sake, the gist of it is that we're exporting crappy block dev values with kernel RBD, and it ends up resulting in XFS thinking that RBD devices are composed of multiple underlying devices and set a really high AG count. It's like 17 in the test that we were running. And that means that like writes, like small file creates, start at many different offsets in different directories. And it all looks random, so the IO scheduler does a really bad job of actually like merging anything. There's tons of unplug events, and performance is really bad. So manually forcing the AG count to be lower, like 4, which is otherwise default, does much better. It's like 2x the create performance, but you actually get a warning from MakeFS saying you shouldn't do this, which so like for users is going to suck because they're going to be like, wait, this doesn't look like it's the right thing to do, but in fact it is. So I think Ilya and Jason are figuring out how to make RBD whether or not they can safely or sanely change what RBD exports so that XFS makes better choices. So they're looking into that, but this is like after days of running block traces and trying to look at like unplug events and wondering why the IO elevator is doing what it's doing, and we finally figured out that it was XFS, changing, doing a different AG count than it used to do because it's like trying to auto configure this stuff now where it used to not. So that's it. Um,
I see. That sounds fun.
oh yeah, it was uh, the game, the Barrel of Monkeys. That's maybe, yeah, that's the closest I can come to describing it. Um, so yeah, anyway, that's hopefully I'm rerunning all of the tests now based on new kernel. Oh yeah, also on the older kernel that we were testing 4.9, it turns out that when we switched RBD over to the block multi-queue stuff, it turns out we did that before there were any IO schedulers available for it. So like N4.9 RBD images will not use an IO scheduler at all. They're unavailable. And not until 4.11. So any users that are using that kernel are like not going to have any kind of like, merging behavior or any other, stuff like that. So, yeah, there's that too. Um, Unfortunate. But anyway, yeah, it's all kind of hopefully being taken care of now to some extent. Um, yeah, that's it for that stuff. The only other thing I was gonna ask Braddock to do is he's been working on like mempool slab allocator stuff, separating them out and kind of improving everything. So Braddock, do you want to talk about that at all?
Uh, let's do that quickly to not lose more people. Okay, so there is a nice pull request, a nice code made by Alan Samuels from SanDisk. I'm resurrecting the idea to behind that code to use a slapped allocator policy just to amortize the allocations of made mostly in STL containers across a bigger number of nodes, just to not have a single tandem of malloc and free for each item on a list, on an STD list. But it turned out in testing that the proposed implementation is highly coupled to our mempool infrastructure. And mempool has actually two disadvantages. First one is the cost of accounting. It's made using atomical operations. Sure, we have sharding there, but still profiling shows it's pretty costly. Second problem is that mempool might be not present in C-star words, so tying to it very tightly isn't a good way. So I just started some weeks ago or something like that to simplify those things, to set a limit on the number of shards to avoid introducing some non-standard method like reserve on map that complicates the design, and most likely will be pretty rarely used. After that, I was able to minimize the changes to basically by a half. I'm testing that stuff basing on quick hacks to use them together with the weighted priority queue, because I saw the huge malloc traffic there, and also on shared LRU. And in profiling, it turns out that, well, it really helps with TCmalloc. It all because of extra, I think that because of providing extra locality, I mean embedded slabs directly inside STL containers, well, it also allowed to squeeze some cycles. I can see now that weighted priority queue takes maybe 60% of cycles it was before.
Nice. That's good.
Still, it needs refination. I mean, I'm just squashing all those commits, making some final cleanups, and I hope to see a pull request this week.
So Radek, when we were talking earlier about this stuff, you mentioned that some of it might be useful in the C-star world, especially in regards to what we're going to have to do regarding like a crossbar, right?
I think so. I wouldn't expect that we'll be able to not have memory flowing between threads, especially at the beginning.
Casey, that was one of the things I wanted to bring up while you were here is, I mean, do you have any insight into what you guys have seen already with your C-star messenger and kind of C-star? I don't actually know how much you guys had before, but just kind of with that whole path.
Very sorry, I was kind of tuned out for the beginning of that. We were talking about passing memory between threads. Is that the context here?
Yeah, Radek has been working on basically the mempool and slab allocation stuff, and trying to kind of separate them out. And the kind of question is, in the C-star world, what are we still going to need to have to do, especially in relation to like memory passing between threads. And I guess I brought kind of the whole thing, I guess.
Yeah. So D-star is basically taking all of the memory available and slicing it into pieces for each core. So memory allocated on one just comes from its own internal allocator, and that has to be freed on the same core. So you can pass it around between cores as long as it goes back to its initial core to be freed. And there's a pointer wrapper that does that.
Are we actually going to be able to use that model though, or are we going to have to like kind of make some kind of nasty hybrid,
Right.
demon spawn kind of?
I think as long as we need to run alien threads, which are threads outside of D-star, we're not going to be able to use that kind of allocation strategy. So for now, we're basically just using the debug allocator, which is just the standard one, and so it doesn't have the same requirements.
What do you think in terms of like the long term? I mean, I guess one of the things I'm trying to just understand for myself is, what does the long term memory model look like here, and are we ever going to get to C-stars kind of
We
kind of
absolutely
utopia
have to get
model?
there.
Yeah.
Yeah, it's mandatory that we do.
Yeah.
Otherwise, we're going to hit locking in the allocator, and
Yep.
that's just not going to be what we want at all.
Radek, what do you think?
Yep, DC is very good when it comes to operating in a boundary of the same thread. But sooner or later, well, if you are doing, if you have malloc, a different thread that accompanying free, well, sooner or later you will see the lock. But still,
I guess
As
Go
far
ahead.
as I read, the locking in PC is pretty fine-grained. Basically, each bucket, each size of space, or each class of space has own lock. So it's rather unlikely to go to kernel. But still, touching atomics, well, it's not it's not it's not so rare, I am afraid.
Actually, I wish that Kifu and Nihao were here. It'd be nice if we could kind of. I think we all want to be able to get to the C-star model. What I'm concerned about is what the path to get there looks like, and when it happens. And um, this is not technical, but from a political kind of viewpoint, are we going to run out of goodwill before we get there, with people kind of just shooting all of this down, saying it's not helping at all, because we're still using alien threads, and we're still doing nasty stuff. And even though we've improved a lot of other things, it hasn't helped because it wasn't actually the thing that we needed to fix, if that makes sense.
Well, I would put much more faith into in evolution instead of revolution.
Yeah, I agree, as long as we can kind of show. At some point, we've got to be able to show that it's doing something useful, right?
Yes, and I think that's the reason why we are going with Messenger as a starting point. If you have
So
enough, yep,
Kipu has already basically created the C-star version of a thread pool, like the alien thread pool, that does message passing back and forth. I don't think it's seen much testing and probably no benchmarking at all. So I think it could be interesting just to play with that, see what kind of overhead we have passing things back and forth, try to look at the memory management at that level.
If we could create metrics for that, showing that we're doing much better than we previously did, I mean, that would be at least something that we could show off. I don't know how much it buys us without being able to show that Ceph is faster because of it, but at least if we've got something that we can say, that helps, right? Anything that we can kind of say, here's one piece of the pie that we've made better. It's only one step, or it's only one thing,
Messenger.
but yeah.
In Messenger, we have a lot of syscalls, not even directly related to sending or receiving data, just even to orchestration of it. I mean, something like putting the scripter to the epool block, control block, or something like that. There's a lot of syscalls there. If we take a powerful enough machine and put 3 OSDs there and move the performance, the bandwidth offered by a messenger component forward, well, we should see a lot more IOPS. Because at least for run treats, we are not bottlenecked by TP OSD TP. We are bottlenecked mostly by messenger. And even the blue store cache shouldn't be a problem because we can always turn it off. Then the size of critical section we have in the bottom part of the pipeline. I mean, in the TP-OSDTP threads, really minimal, should be really small.
That reminds me, one of the things on my to-do list is get the pet store vector object stuff ported to master as part of memstore, because it's pretty easily separatable, and honestly, it's the best part of pet store was the vector objects. The rest of it was kind of not helping or just kind of changing things around, but that was the real thing that
Mark,
made a big difference. Yes,
do we have some any results from benchmarking DPDK with current async messenger? I saw that
I don't.
we have that backend,
Mhm.
and I think that employing it effectively, I mean, with sister-based messenger, might be the key factor to go.
Nope, we've got nothing. The last time I tried it, it crashed, and then I
Okay.
never tried again. So yeah, no, it's a valid area for exploration. It might work fine now, um, but I just haven't looked at it in a long time.
We stand up in a minute, but before I go, I wanted to talk a little bit about work. You saw some stuff about Adam's work on the Objector and the ASIO stuff.
Yes,
So I want to get some more visibility around that project. So maybe next week, Adam and I could present a little bit about it and kind of say what the high level goals are there.
absolutely. I think that would be great.
It sounds like we should have a PR open for it to talk about also.
That sounds really good. I think that for me that's really exciting. When I saw all the traffic on this recent PR and then Adam's PR, upcoming PR, that sounded really exciting. So I think it'd be great.
Well, I'll talk to you guys later. Thanks.
Talk to you later, Casey. All right, I don't have anything else to talk about. I think we've pretty much covered everything this week. Anything, Josh or Radek, you guys want to bring up before we wrap this up?
Nope, nothing else on my mind.
All right, cool. Well then let's be done, and next week we can talk about Casey and Adam's ISIO work. That I'm excited about that. So I guess
That
have a
sounds
good week,
great.
guys.
Thanks. You too.
Thanks, same for you. See you later. Bye.
Bye.